Alright, welcome to the next video series on loops. We're going to start with the for loop. The for loop is used when you know how many times you want your code to repeat. We use three different expressions as part of that for loop, and you can see here that expression 1 is responsible for initializing that loop count variable. In this example, we've assigned I to be a value of 0. The second expression is our conditional expression, which tests that loop to see if it's true or false. So this expression will evaluate a Boolean value of true or false here. In this case is I less than or equal to 10. Well, it's got to be true or it's got to be false. Expression 3 is executed at the end of each iteration or loop. And it's usually used to modify that loop count variable. In this case, because we've got an example of I++, we would just add 1 to that loop count variable I. So if we look at this flowchart example, you can see that the first expression is when we establish that initialized value of 0, and we're assigning it to I. And we go to the second expression, which is the conditional expression, which asks, okay, is I less than some number? If that's true, then we're going to execute the statement. It could be a compound statement, it could be several compound statements, it could be one expression statement. It depends on the program. Once that's finished, this is one iteration. Then we go and evaluate expression 3, which in this case adds 1 to I. Now, notice that we don't go back to expression 1, because if we did that, then expression 1, which is assigning a value of 0 to I, would mean we'd be starting all over and we'd never get out of this loop. So after we're finished this expression, we go immediately to expression 2 and we evaluate it again. Okay, now because I is 1 less than that value, okay, and we continue on in this fashion until this becomes false and then we're out of the loop. This example really demonstrates that. We have I being declared outside the loop here, and our initial expression says, okay, assign 0 to I, as it did in the example previous to that. And now we've got our conditional expression, which is saying, is I less than 5? So if I is 0 less than 5? Well, yes, it is. So what do? Well, we go down here. We execute our statements. We have a compound statement, which is made up of one expression statement, and it outputs this code right here, loop iteration, and whatever I is. Well, I happens to be 0, so that's why we get loop iteration 0. What happens next? Well, we execute this third expression, and that adds 1 to I. So because I was 0, it's now 1. We go right immediately to that second expression and evaluate that conditional expression again. Is 1 less than 5? Yes, it is. So we go execute that set of statements again. If that statement, has a 1 attached to it here, so loop iteration 1 is output. And then we go back up to this expression here, which then gets modified to add 1 to I, and the whole thing repeats. Now, what you'll notice at the end is that I actually becomes 5. Okay, that's the very final value of I. And the reason for that, if you look at after this one becomes 4, we add 1 to I, which becomes 5. It evaluates the conditional expression, and the question again now becomes, is 5 less than 5? Well, no, it isn't. It's false. It's out of the loop. But the last value of I is actually 5, and that's how we get out of that. Okay, the next kind of loop is a while loop. So while loops are much simpler than for loops. As you can see here, really all that exists in the middle is expression 2 from the for loop. And we would use these while loops for conditions. Maybe if a sensor is tripped, or maybe if a couple of buttons are switched, okay, based on some condition, not based on the number of loops or iterations we want, like in the for loop. It's simple, exactly the same logic that we used before. If this expression is true, statements are executed, and you continually evaluate this expression over and over again. If it's false, then you're out of the loop. Okay, it is possible to have this expression false, which means that you'll never execute the statement at all. So let's look at this while loop flow chart. So we start, expression gets evaluated. If it's true, execute the statement, go back to the top, evaluate the expression. If it's true, execute the statement, and here's our loop. As soon as we're false, we're out. Here's our while loop example. All I've done here is I've taken from the for loop, okay, we've taken this example and they have just simply, instead of declaring I here, they've declared it and initialized that counter to be 0. Okay, and then we've added I++ after our statement. Well, that's the same as the for loop, isn't it? So when I is 0, that condition gets evaluated here. This conditional expression is 0 less than 5. Yes, it is. Execute the statement. Okay, it prints 0, and then it adds 1 to I. Well, where does the control for the program go? Get back up to the top, you're right, and then it evaluates that expression again. Is 1 less than 5? Yes, it is. So execute the statements. Print this, which is 1, and then we add 1 to I. So it's exactly the same as a for loop in the way it's written there. Okay, but again, we use these more for conditional loops. The expression for the while loop must always be there, unlike for a for loop. And as I said, it's used more often than for when implementing an infinite loop. You would have seen this already, but again, a matter of personal taste. But if you think about embedded controllers like a smoke alarm, you always need to be checking for inputs. So these infinite loops are crucial. So the while 1 is a common way to do that. 1 is always going to be true, so therefore this will always loop everything inside those braces. If you happen to place a semicolon at the end of this loop, as one student I know did today, then you would notice that that would be a nothing statement, and it would execute nothing right here. And these opening and closing braces, this statement block, would never be executed because the loop would be stuck up here. Okay? So be careful with that. The do while loop. All right, the do while loop is exactly the same as a while, except that the statement gets executed at least one time. Then the expression is evaluated. Okay, so statements will always execute at least once, even if that expression is false when the loop starts. Okay, so you can see here right off the top, the statement gets executed. Then that expression is evaluated. If it's true, then the statement is executed again. If it's true again, it continues in this fashion until it's false, and then you're out. What does that look like? Well, you've got the do up here with the curly braces open and closed with the while loop, and you have a semicolon at the end here. So keep that in mind. That's just the syntax, the way it's written. Again, exactly the same code as what we saw in the for loop. You have the initialized value of I is 0, and you're adding this little piece of code here at the end, which is incrementing I. Okay, so all you're saying here is that, okay, I has been assigned a value of 0. Okay, first thing happens, well, we execute that statement. There is no condition to go through. Condition's at the bottom. So we execute that, loop iteration is 0. And then this expression is examined. So is 0 less than 5? Yes, it is. So that goes back up to the top. That statement is then executed again. So before that happened, we added 1 to I. So now this loop iteration 1 executes, and it outputs to this output window. And we continue on. Again, I would be, the final value of I would be 5. Even though it doesn't show it in the window, I would be 5. Okay, break statements cause immediate termination of a loop, and they can also be seen in a switch statement. When we get to selection structures, we can see that. So a break statement, this is a flow diagram within a while loop. You can see the start here. The expression gets evaluated. If it's true, the statement gets executed. But then if it comes upon a break, okay, then it's right out of the loop completely, and it doesn't matter what this expression statement says there. The break takes it out regardless. So you can see here this example works with when the break occurs when I is equal to 5. So it starts as 0. The while statement says, okay, keep continuing to loop as long as that I is less than 10, and we're going to add 1 to it. So the very first iteration is going to be 1, okay, and it continues on in this fashion, looping until it gets to 5. As soon as it hits 5, it's out of the loop, and it doesn't have a chance to print loop iteration 5. So that's when it breaks there, and we end up with the same similar code. It's not the same because we start at 1 and we end at 4.